Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk a little bit about how to pick a wave height when you're evaluating motion affected comfort in the Ship Motion toolbox. So we're going to use the 50-meter generic yacht for this example, and what I've done ahead of time is generated a motion RAO of the bare hull, and we're going to be using this just as an example here. Now, when we load up the Ship Motion toolbox, first we got to load the RAO, and there's the motion RAO here. Oh, another thing to point out is if you want to quickly define and use some areas that go along with the generic yacht design, if you click on the generic yacht 50-meter areas.txt file, this is included in the sample files, and just highlight these areas, hit Control-C to copy them, and then go back here and click Paste All. It's a great way to just quickly get the areas that are defined for these generic yachts included in the file. And of course, you can do the same thing for your projects. If you want to save the locations, it's a quick way to get them in there. So now, these motion affected comfort ratings are based on the ISO standard for motion affected comfort for large yachts. And I believe the intent for this is to use a significant wave height of 1 meter, but it is technically a little bit ambiguous in the standard about using bind probabilities for bind data in the range of 1 to 2 meters. So what I might suggest you do is whatever you do, whatever wave height that you do use, make sure that you've got it reported along with the comfort rating that you have. Now, let's write some notes here. 50-meter generic yacht bare hull. Let's just take the 1 meter wave height and then run a comfort analysis on the bare hull. So this is without any stabilization, and what we'll find is the comfort rating is quite high. So at 0 speed we have 97. This is the aggregate 95. 0 speed 97 and 12 knots. I mean, things are looking pretty good for this 50-meter yacht design. Now, this might be sort of acceptable, but also it's not really giving a lot of room for feedback on what might be happening as we go through some sensitivity studies for the purposes of evaluating the design. So and improving the design. How can we use this to help us? So let's just put it at the other end of the scale and see what happens. So we'll put in at the upper end of the scale. Now it won't the software won't let you go higher than this because behind the scenes it's using wave probabilities associated with that bind range of 1 to 2 meters. So we do the comfort analysis again, and so what's happening here is the ship motion analysis is being all the incidence of motion sickness, the MSI, and the effective gravity angle of the ship, and all those locations are be evaluated at 4 seconds, 2 meter, 4 second waves, 2 meter, 4.5 seconds waves, and so on. So this is really severe conditions, and the comfort rating is extraordinarily low. So this has kind of gone too far the other way. Like, it's so low that anything that we do could potentially make it better. But I mean, the other thing is, like, you don't have a lot of room for seeing that sensitivity of variation when things kind of get worse, because we're already at 8.5%. That's so low. So let's go back in between, in the middle. Just pick 1.5 here. Now, for the purposes of doing getting feedback on design, what happens when we change the vertical center of gravity up or down, or we look at what happens with anti-roll technologies or whatever. Now we've got a comfort rating of 44.7% here. You're in a space where the comfort rating is kind of giving you some feedback that you can when you make some adjustments, you can see what's happening. So again, regardless of whatever you're doing, make sure you're reporting the wave height that you're working with. But now this is for a 50-meter generic yacht. You may find that, like, obviously smaller yachts than the 30-meter range, they're going to be much more sensitive to 1 meter wave heights than a 50-meter yacht, and you know, the reverse will be true. A much higher, larger yacht, a 60-meter, 90-meter yacht, we'll see you might need to use a higher wave height to just see if you can get some sensitivity out of it. So, you know, for the purposes of an internal development, internal design process at the early stage, you may want to, you know, make some adjustments to the wave height and see, you know, it's not just about the absolute comfort rating. You want to see how it's changing when you make changes to the design. So then the RAO changes, and then you can make some comparisons and see which way the design is going better when you make a little bit of an adjustment to the wave height. Hope that makes sense. I wanted to give a bit of feedback on like why would you want to make some adjustments and how do you pick the wave height to use. Thanks for watching.